In this video, I'm going to show you how to factor the greatest common factor out of a polynomial. But first, what I want to talk to you about is an example that's already factored for us. And what I want to do is show you that when you factor the product, you find the GCF for both terms, and you look at both terms, what is the greatest common factor that they have in common, and then I'll show you how to take that out. So this is kind of the example already done for us, and we've been already watching 2 videos on the greatest common factor, but here in this video, I'm going to show you how to kind of put it all together. If I were to distribute my 6x times x and 6x times 5, well, 6x times another x would be 6x squared, and 6x times 5 would be 30x. What if I started with this, like we had started in other problems, and we found the GCF? Well, the greatest common factor that 6 and 30 have, well, they are both divisible by the number 6, so that's the biggest factor that they have in common. So that's what we take out of the problem. And then both of these letters, between x squared and the letter x, the smaller of the power is x to the first. So if we take that out of what we started with, if I divide out a 6 and an x from 6x squared, I'm left with 1x left over. And if I take 30 divided by 6, I'm left with the number 5. And if I take the x outside, there's no x's left. This is what is called factoring by the greatest common factor. And so essentially what you do is you first find the greatest common factor, which is what we did here, the 6 and the x. And what you do is take your problem that you started with, your polynomial, and you divide out the greatest common factor from each of the terms. And this is what is called factored form. And so I'm going to do 6 examples with you on finding the GCF and then factoring that out, meaning dividing it out. So between the two numbers 40 and 24, if you need to make a list of those two numbers, go ahead, write out all the factors, but the greatest common factor here is going to be the number 8. And between x cubed and x to the 5th, the smaller of the powers is the 3, and so what we're going to do is factor out 8 and x cubed. And we're going to see what we get left over after we divide by 8 and x cubed. Well, 40 divided by 8 is the number 5. And if I had 5 x's and I take 3 away, I'm left with 2. And now my plus sign connects those two terms. 24 divided by 8 is the number 3. And I know that that's the greatest common factor with my number terms because 5 and 3 have nothing in common except for the number 1. So I know we found the largest number. And then if I had x cubed and I take all the x's away, there's no x's left over. So this is what is called your factored polynomial. So we factored out what is called the GCF, what's in common in both. Now for the number 10 and the number 3, for my next example, they have nothing in common except for the number 1. There is nothing that goes into both of those numbers because 3 is what is called prime. Its only multiple is 1 in itself. And the letter G and the letter G with the 3rd power, the smaller of those powers is just the letter G. So the only thing that these have in common is the letter G. And now what I'm going to do is take 1G away from those terms. So from 10G cubed, if I take away 1G, I'm left with 10G squared. I have a minus sign that connects them both. And if I had 3G and I take the G away, I'm left with 3. And this is what is called factoring by the GCF, is you divide that greatest common factor out of both terms. Now for the numbers 35 and 42. Well, I have a negative 35, but the other number is a positive 42. So I can't take a negative out of both. But I know both of these numbers are divisible by the number 7. And then between x and nothing, no letter, the greatest common letter is no letter because one of them had no letter to take out. So if we only divide each term by a 7, I'd be left with negative 5 and x because negative 35 divided by 7 is negative 5. And 42 divided by 7 is the number 6. Now 5 and 6 have nothing in common. We actually did this problem, I think, in our video on a previous page. I'm just going to double check. Yeah, we did. GCF between 5 and 6 is just 1, so that makes sense to me that that's the same thing that we had here. There's no GCF in common between those numbers, so I know 7 is the largest number that we can take out of 35 and 42. Okay, now we have 3 more. Let's see if you got the hang of it, and we'll do 3 more examples. If you want to, try to pause the video and see if you can solve these 3, and then hit play and we'll check your work. Between 160, the greatest common factor that will come out of both of those is the number 20. 20 comes out. And now I'm going to do my A's and my B's. A to the 8th and A to the 10th. The smaller of the two is A to the 8th. And now for my B's, B to the 5th and B to the 8th for my terms. The smaller of the power is B to the 5th. Now why am I saying the smaller of the power? Because in a previous video, we talked about the GCF would be the greatest common for your coefficients. So between 27, 3, and 9 for this example that we did, the largest number comes out. But for your variables, it's the smallest exponent that you can take away from every term. And so that's what we're looking for here, is the smaller of the exponents that they share. So these 3 we're going to take out of every term. We're going to divide by 20 and A to the 8th and B to the 5th. Now 100 divided by 20 is 5. If I had 8 A's and I take them all out, there's no A's left. And if I had 5 B's and I take all the B's out, there are no B's left. Now for 60 divided by 20, I get the number 3. If I had 10 A's and I take 8 of them away, there are 2 left over. And if I had 8 B's and I take 5 of them away, there are 3 B's left over. And this is my factored form of my polynomial. All right, now we're going to have 3 terms in this one between the number 30 and 10 and 12. Actually, it's a negative 12. What's the largest number that all of those numbers are divisible by? Honestly, the biggest one I can think of is 2. 3 is not going to go into each of those. 5 doesn't go into each of those. 6 doesn't go into each of those. And that's about as big as you can get with the number 12. 12 doesn't go into 10. 10 doesn't go into 12. So 2 is going to be our largest number factor. Now for the letters, x to the 7th here, x to the 13th here, and x to the 5th here. The smaller of the power is x to the 5th. And for the letter y, y to the 10th, y to the 12th, and y to the 6th. The smallest of the powers is y to the 6th. So I'm going to put those 3 things together for my GCF. 2x to the 5th, y to the 6th. And now I'm going to divide. 30 divided by 2 is 15. X to the 7th, my term here. X to the 7th, if I take 5 away, I'm left with 2. Y to the 10th, if I take 6 away, I'm left with y to the 4th. Now my next term, 10 divided by 2 is 5. X to the 13th, if I take 5 away, I'm left with 8. And y to the 12th, if I take 6 of them away, I'm left with 6. And then for my last term, 12 divided by 2 is 6. Well, negative 6. There's a subtract sign there. I took all 5 x's away, and I took all 6 y's away. And so this would be my factored polynomial with my GCF. And now for number 18, the last one here for our greatest common factor. I notice that I have 2 negative numbers. So I'm going to take out a negative, and they're both divisible by 5. And then for my g cubed and the g squared, the smaller of the power is g squared. So we're going to divide both of those by the negative and take out 2 g's. Now the negative taken out, I'm going to have a positive number. 5 divided by 5 is 1. G cubed, if I take 2 g's away, I'm left with 1 g, and that's it. Now I took out the negative, so that I'm going to have a plus sign here. Negative 15 divided by 5 is a 3, and we took both g's out, so there are no g's left over. And that's what we get. Can you see it now? I hope you got your GCF down. If you need more practice, feel free to reach out to your teacher.